And let me grab this, and grab this, and grab this, and grab this, and grab this. And so guys, here we go. So these are the things that we are going to be about doing today. Guys, what you're going to find, and you can actually see this if you allow your eye to scan through the notes, and we'll do this together. So guys, this is the order that we're going to roll things out. Look at slide number 2. The first thing that you're going to learn are some skills. These are things that you've got to be able to do. You're not going to be great at it, but I want to see you doing your best to try. Then guys, if you flip over onto the second page, you'll notice there's another title slide that says techniques. So guys, what I'm going to do in that section is teach you how to do better, things that you could probably do on your own, but you won't be doing them with the correct techniques. So under that section, we're going to teach you some techniques. Then guys, what we're going to do, looking at the next title slide, it says concepts and calculations. Guys, what we're going to do is we're going to reach back into that activity that we did several days ago where you went and made measurements over in Miss Call's lab and you were thinking about significant digits and things like that. Guys, we're going to bring all of that information forward. We're going to talk about the ways that we apply measuring and significant digits in lab. And guys, when we're done with that, you'll notice that we're out of slides, we're done for the day, and you'll have some time to work on your. Then it goes concepts and calculations. So guys, with that said, settle in, and these are the skills that you need to have. So guys, the first skill that you need to have is you need to be able to light a Bunsen burner. So guys, I'm going to show you how to do this, and I'll be honest with you guys, this looks amazingly simple, and for some of you, this is going to be one of the most frustrating things. Gas, and then I'm going to spend some time and show you how to light. All right, so guys, when we talk about Bunsen burners, the first thing you need to understand is why we use them. And the answer is we use Bunsen burners to heat substances over in lab. So it's kind of like our stove. It's like our cooktop in lab. So guys, in order for you to understand how to light a Bunsen burner, I think it's going to be helpful if you understand how these things work. So guys, first thing is this: never be afraid to handle a Bunsen burner. Many times people will just leave them on their countertop and they don't want to touch them. Guys, dig in, get your hands on these things. Don't be afraid to pick them up. So guys, this is the way these things work. They are connected by a tube to a gas source. And guys, these are these taps that are up on your countertops. And guys, what you're going to see is that when you turn these on, they actually dispense natural gas. The same gas that heats your home if you don't have electric heat. Guys, this is just a natural gas source. We use it as a source of energy in lab. So guys, the way that this works is this will be connected to this. Because you never need to disconnect that, but I will just so I can show this to you. But it goes gas through the hose into the Bunsen burner. Now guys, in order to understand how this works, let me show you how a Bunsen burner works. And the way this goes is the gas goes in this side. And when it goes in this side, actually it's a 90-degree bend. Guys, in here is an elbow that allows this gas to go vertical. And when it does, it goes through this very little hole that's called a needle valve. And so this valve right here actually accelerates the gas and shoots it up the barrel of the Bunsen burner. Now guys, down at the bottom here, there's actually a needle. And the way that this works is this needle screws up and down, and when that needle is screwed all the way up, what happens is the needle plugs the valve and it doesn't allow the gas to go through. So, guys, when you're lighting a Bunsen burner, and you don't need to take it apart like this, but it's helpful to understand how it works. When you light a Bunsen burner, eventually what happens is the gas goes through here, up the barrel, and then it burns up here. That's what you're trying to do, is get this thing lit. So guys, in order to light a Bunsen burner, here's what you do. The first thing that you do when you're lighting a Bunsen burner is you want to shut down the burner. And here's what that means. Guys, you're gonna pick this thing up, you're gonna grab the valve at the bottom, and you're gonna screw it all the way closed. Then guys, the next thing you're gonna do, and can you see this? Can you see these holes in the barrel? Can you see those from there? The next thing you're gonna do is the barrel, and you're gonna screw that all the way shut as well. So everything is closed down. Then guys, the next thing you're going to do is you're gonna turn on the gas. And here's the way that this works. Can you guys see this handle right here? It's a little distant. But guys, the way this works is there's a nozzle on the Bunsen burner, and anytime the burner and the valve and the nozzle are perpendicular, it's shut off. Anytime it's parallel, it's open. So guys, this is on, this is off, this is on, this is off. So what you're gonna do is this. You're gonna turn on the gas. But guys, the gas is not flowing. Why is the gas not flowing? Because everything is closed off. So now guys, step number 3, you're gonna open the needle valve on the burner. So you're literally gonna pick this up, and guys, you're gonna open the valve, and feel free to stick this next to your ear unless it's hot. Guys, put this next to your ear. Can you guys hear that? Guys, the gas is now flowing, and I'm not gonna leave it flow because it's gonna fill the room with gas. But guys, the next thing you're going to do then is you are going to light the burner. And guys, this is how you do it. We do not use matches to light burners because then we throw matches in the trash and the trash can catches on fire. Guys, we use one of these to light the burner, and this is how to do it. You got to do this right. Guys, you might want to write this down in your notes so you don't screw this up, not so you don't forget. So guys, here's what you're going to do. Write down the word left-handed gun. Remember this, I promise it works. So here's what you're gonna do. In order to light the burner, you're gonna get a left-handed gun, okay? And then here, and it's gotta be left-handed. If it's right-handed, it doesn't work. So guys, you're gonna get a left-handed gun, and you are going to stick the hood of the striker on the barrel. So you might wanna write down hood on barrel. Then guys, once you've got the hood on the barrel, you're gonna hook the hammer on the arm. So hammer on arm. Then guys, the last step is squeeze. So here's the deal. Let me show you how this works. So what's gonna happen is when you go to light your Bunsen burner, you're gonna grab this striker and you're gonna squeeze this thing until your hand cramps up and it's never gonna spark, so it won't light. Here's what you gotta do. Hood on the barrel, hook this with your thumb, and then when you squeeze, this thing sends sparks everywhere. But if you don't pinch this, it won't spark. So it's not this, it's this, and that's what makes the spark. So this then is what you do. You got this thing, gas open, you get your left-handed gun, you bring this over here, and now your Bunsen burner's lit. Now guys, here's the problem. While you did light your Bunsen burner, the problem here, guys, is that this flame will never accomplish the things that we want it to accomplish. This flame is flickering. This flame is not hot enough to do the chemistry that we need it to do. So guys, at this point, what you've got to do is you've got to adjust the flame. And here's how you do it. The height is adjusted by the valve, and then the barrel is used to adjust the heat. So here's what that means, and you may want to take note of this as well. Guys, the first thing you're going to do is you're going to pick up the Bunsen burner and you're going to grab the valve and you're going to adjust this until the flame is about, what would you call that, 4 inches? Maybe 4 or 5? Guys, adjust the flame until it's about 4 inches tall. You may want to make note of that. Adjust the flame until it's about 4 inches tall. Then guys, once you've got that, so then guys, here's what you do. It's now time to increase the heat by adjusting the barrel. So guys, don't grab the barrel at the top, it's hot. Grab it at the bottom and then twist this open. And guys, watch what happens when I twist this open. So what's gonna happen is as I twist this open, it opens these vents down here. That allows air to get sucked into the gas And guys, look what it does to the flame. It takes that orange-yellow flickering flame and it turns it into something that looks like this. And guys, that is what you're shooting for. If your flame doesn't look like that, you are not okay. So guys, one of the first things you've got to do in lab on Friday is figure out how to light your Bunsen burner and achieve that tight flame. Do you need more on that? Is that okay? Okay, so then guys, once you've got this thing all dialed in, the last thing that you need to do is this, because we use Bunsen burners on ring stands. So what you're gonna do once you have this all dialed in is you're gonna put your Bunsen burner, sorry, I keep blowing this out. Guys, you're gonna put your Bunsen burner on the ring stand, and then you're going to adjust the ring until the ring is right at this point right here, which is the hottest part of the flame. So you're going to adjust that right like that, sit this on here, and that's all ready to go. Does that work for you? And guys, again, when you get into lab, don't be surprised if this is harder than you thought it is. Frankly, it is a little more involved than I make it look, but that's the idea. And then guys, importantly, the last step, when you're all done with this, in order to shut off the Bunsen burner, guys, the trick is this. Don't shut it off at the burner, shut it off at the tap. By the way, guys, when you get over into lab, what you may find is that one of your partners is more comfortable lighting a Bunsen burner than the other. Guys, please, both of you get good at this because you need to know how. The other thing to know is this. Guys, these are not in your drawers. These strikers are not in your drawers. They actually hang on the sink over in lab. So when you need it, it's hanging right there on the faucet. Please put it back when you're done. So guys, are we good on Bunsen burners? Okay, what's the next thing we're going to talk about? You have the notes. Using a balance. Okay, so guys, the next thing we need to talk about is how to use a balance. And I think you're okay with this stuff because we talked about this when you went over to do the measurement activity. But guys, let's just be sure, and if you have questions, please let me know. So guys, step number one is this. First thought is this: never ever put chemicals on a balance. Anytime you need to weigh a chemical, guys, put a weighing boat. Remember these things? You put water in it. Guys, put a weighing boat on a balance, and then you can go from there. The thing you don't know about weighing boats is this, though. Guys, watch so you know. Guys, weighing boats are actually really cool because if you weigh out a chemical in a weighing boat, if you pick this thing up and grab it from the corners and pinch, it actually forms a spout and you can pour from it. So guys, these things actually work that way as well. So never put chemicals on a balance, always use a weighing boat. Guys, thing number two, make sure you re-zero a balance every time you approach it. Just get used to that. On our balances, the re-zero button, which some balances call the tear button, is down here in the lower left corner. Make sure you're re-zeroing your balances. And then guys, finally remember, we don't estimate one digit past the device because it's a digital readout and you can't. So guys, you know they look like this. Any questions on balances? You guys all good on that? Guys, I would circle this idea of re-zeroing. Guys, make sure you're re-zeroing your balance every time you go to lab. Again, a lot of that's review, but I think it's worth mentioning. You guys good there? You're good? Okay. So guys, now the next thing, reading graduated cylinders. So guys, this came up during the measurement activity, but frankly, unless you ask me directly, I didn't address this with you, but we need to talk about it now. So guys, the information that you need is up here, but it goes like this, and some of you noticed this. Guys, when you were making measurements off of the graduated cylinder, did any of you notice this? I don't remember which classes did, but guys, when you have water in a graduated cylinder, did you notice that the water forms a dip? Do you guys know why? You might have learned it in biology. Do you know? It absolutely does. It's called capillary action. And actually what happens is the water is attracted to the glass and it gets drawn up the side. Guys, this is a term you need to know, so I would circle it. Guys, that dip is called a meniscus. You need to use that word intelligently. Guys, that dip is called a meniscus. So guys, the question is, what do we do with that? When we make a measurement with the graduated cylinder, how do we deal with the meniscus? Well, first of all, there's another term you need to know, and then we'll pull these together. So guys, the other term you need to know is what is called parallax. Parallax, as you see there, and again I would circle this too, is error made in measurement caused by misalignment. So guys, this then becomes the way you read a graduated cylinder. So the first thing that you need to know is that when you read a graduated cylinder, you always measure from the bottom of the meniscus. And this is not going to be in your notes, so I would write it down off to the side. Guys, you always read from the bottom of the meniscus. But then, guys, the other trick is this. When you are reading from a graduated cylinder, do you see the problem with this? Why is this bad? Guys, because I'm reading it at an angle. And if I'm reading at an angle, that angle is going to cause an error in measurement. Again, what do we call that angle? Parallax. So guys, how do you avoid parallax? You got two choices. You can either drop your butt or you can raise the cylinder. And guys, honestly, I prefer to drop my butt because that allows me to leave the cylinder on the table, and then I can drop my butt, get down here at eye level, and that allows me to make the measurement. Guys, be careful that you're not doing this because that's going to add error to your measurements. Does that make sense? Okay. So guys, with that said, in your notes next to this diagram, write down the volume that you would write down if you were making this measurement. Please do this, because guys, this is critical that you understand this. We talked about this during the measurement activity. Please do this in your notes, because if you're doing this wrong, I want you to have the experience of going, oh, that's not right. So when you do it in lab, you do it right. So guys, let's talk about what this measurement might be. So the idea is that here we've got 40, 41, 42, 43, 44. So guys, we are sure that this is more than 44. So we're going to go with 44 milliliters. But why is that number not right as it's written? Exactly. Guys, you have to estimate 1 decimal past the accuracy of the device. So if this measures in whole milliliters, we have got to estimate to tenths. So maybe 44, and again, remember we measure from the bottom of the meniscus, what, 44.7 or 44.8 or something like that. So guys, make sure, this is important, if you need to write something in your notes to remind yourself, it is in your notes. Guys, you will always estimate 1 decimal place past the accuracy of the device, so maybe something like 44.8. But guys, understand we're not done yet. It's still not right. What's missing? It's got to be units. Remember guys, when we make measurements, we communicate the type of measurement we made by units, and our graduated cylinders measure in milliliters. So guys, again, these are things you're going to be accountable for in lab, estimating a decimal place past the accuracy of the device, and units on your numbers. So you guys good there? Is that okay? Okay, so guys, we've got 3 things then. We've got balances, Bunsen burners, and graduated cylinders. Anything you need to talk about? Because we're about to shift gears. You okay? Okay. So guys, the next thing we need to talk about then are, actually the 4th thing we need to talk about is filtering. So guys, one of the things that you're going to be doing in lab on Friday is you're actually going to be filtering a mixture and filtering off the liquid. So guys, I need to show you how to do this. So let me talk you through the steps, and then I'll show you what this looks like. So guys, when you are setting up a filter, the first thing you're going to do is fold the piece of paper in half twice. Once you're done with that, you're going to open this up between pleats 1 and 3, and then you're going to clip the corner out of the outer pleat and then put it in a funnel and get it wet. So guys, let me show you how this works. Again, you're going to be doing this over in lab on Friday, and you're going to be doing this quite a bit through the year. So let me just show you how this goes. So guys, when we filter, the first thing that we need is a piece of filter paper. It looks like this. It comes in sheets. And the way this works is we need to figure out a way to get this piece of filter paper to fit in a funnel. Because eventually what we're going to do is we're going to dump this through the funnel, and a solid will stay behind and the liquid will go through. We use this to separate solids from liquids. Here's the way you do it. Step number 1, you take the piece of paper and you fold it in half. Step number 2 is you do it again. So guys, at that point, you've created a cone that looks like your funnel. Then guys, this is the tricky bit. Step 3, it says open it up between pleats 1 and 3. You'll notice there are 4 pleats. You want to pick a place where you've got 3 pleats on one side and 1 on the other. And when you do that, you actually end up with a solid cone that you can use to filter. But then you'll notice you got this flappy flap down here. Guys, that's what step 4 is about. What you're going to do is you're going to rip the corner off of that flap. So you're not ripping it off of the part you're going to filter with, you rip it off the flap. Then guys, once you've done that, what you're going to do is you're going to take this and you're going to put it in your funnel. When you do that, it then fits the funnel. The problem is it comes out. If you let go of it, it comes out. So then all you've got to do is come over here, get this thing wet, just like so, and you're good to go, and that does the job. You get the idea? Does that make sense? And then guys, eventually what you'll do, and this funnel's a little bit too small. Well, it's not. Then what you'll do is you'll take this funnel and you put the tip of the funnel in this clamp, and then you can hold this over the thing that you're filtering into, and that allows you to filter like that. You guys good? We good? Okay, so guys, we've got those 4 things. Again, my intent is that you don't do these things perfectly on Friday. My intent is that you're just doing your best given what we talked about. When you have questions on Friday, please let me know. Good? Okay, so now guys, moving along. We're now ready to talk about some techniques. And guys, as we talk about these techniques, I got to share a term with you that you need to know. And it goes like this. It's not in your notes, but you may want to write it down over here. Guys, the critical thing that you need to avoid in all of these techniques is what is called contamination. So the bottom line is this. What I'm about to teach you is how to walk up to the front of the room and get a sample of a chemical in a way that gets you what you need, but doesn't contaminate everybody else's lab. Because guys, if you do this wrong, there's the possibility that you can get contaminants in the classroom supply of chemicals. And if you do that, you can screw up everybody else's lab. So when we talk about these dispensing techniques, what we're trying to do is avoid contamination. Guys, because contamination can mess up people's labs. So guys, the first thing that you need to learn how to do is you need to learn how to pour. And this sounds kind of crazy, but this is the idea. Imagine that we go into lab and the lab says, and I'm just going to fill this with water. Say that the lab says that you need 20 milliliters of water. And so guys, you come into lab and you've got your graduated cylinder because you know you need your graduated cylinder to measure a volume. So guys, you come up here to the front of the lab and you're ready to go and you're like, okay, this is my bottle of water. And you come up here and you grab and you get your 20 milliliters of water and you sit this down and you walk away and people are coming and going. And guys, if that's the way you're going to approach this, there's all sorts of problems that you've created for everybody else in lab. So guys, let's talk about this carefully and let's make sure you understand how to do this. So, guys, when you come up to the lab to get a liquid chemical, here's what you do. When you come to get the liquid, what you don't ever want to do is set the lid down. The reason is if we're in lab and if we've got all this stuff and if we've got bottles and if we set all these lids down, at the end of the day when we go to clean up, we don't know which lids go with which bottles and we can contaminate stuff. So guys, the trick then is this. Whenever you go to get a liquid, never ever put down the lid. So guys, step number one, I would underline or highlight that or something. Guys, never ever set down a lid. So this is the way that this goes. Say that the lab says you need 20 milliliters of water. Here's what you do. Come up, find the bottle that you need, take the lid off, and guys, never set down a lid. The lid goes immediately in your palm, and then you grab it like this. Hide the lid in the palm of your hand. That way you never set it down, so you always know where the lid goes. Then guys, you're going to come along and you're going to get the amount of liquid that you need. Now guys, watch. So I need 20 milliliters and I just got too much. Put it back? Why not? Yeah, guys, you're going to contaminate the bottle. So guys, if you get too much, you never ever, don't let me ever see you pour back into a bottle because your graduated cylinder is not clean. And if you pour back into here, you just contaminated everybody's supply. So if it's safe, you can put it down the drain. If it's dangerous, you'll put it in a waste bucket. But guys, never pour back into a supply bottle. You'll go like this, get the little bit more that you need. Now that you've got the amount that you need, you just grab the bottle, screw the lid back on, and you're all done. Does that make sense? Is that okay? Now guys, what does this last one mean, number 4? It says always use a graduated cylinder. Guys, please be careful of this, and you may want to make note of this. Again, I know this is a lot of information, but write it down with me. Guys, never measure volumes with beakers. Never measure volumes with beakers. These are not accurate. Anytime you're measuring a volume, always use a graduated cylinder, never use a beaker. You guys good on that one? So important things to remember, always palm your lids, never pour back into bottles. You guys doing okay? Am I doing okay? I feel like I'm like babbling. Is this really making sense? Can you tell I'm asking you a lot? Guys, honestly, I'm struggling. I don't know if you can tell, but okay. So guys, the next one we need to talk about then is what is called transferring. So this is the idea. Imagine that you go into lab next time and the lab says this. You need 1 milliliter of a liquid. Now guys, here's the problem. The bottom line on a graduated cylinder only goes down to 5. So guys, how are you going to measure 1 milliliter of something if the cylinder only goes down to 5? Do you remember what you did over in the activity? Do you remember? How do we measure small volumes? You guys remember this thing? Remember when you measured a milliliter of water in station 15 and then you found its mass? Guys, this is how you do it. So let me show you how this goes. Anytime you need a small amount of something, you don't pour, you transfer. And guys, this is the way that this goes. Some of you struggled with this over in the activity. Let me show you how. If we ever need a small volume of something, there will always be a dropper attached to the bottle. Now guys, the top line on this dropper is 1 milliliter. So here then is how you would get 1 milliliter of a substance. So guys, you're gonna take the lid off the bottle, set it down, and then grab the dropper. You're gonna take the lid off the bottle, palm it, grab the bottle, and then grab the dropper. Then guys, what you're gonna do is you're gonna squeeze the dropper, stick it in the bottle, and you're gonna slurp this thing really, really full. You got more than 1 milliliter. So guys, what are we gonna do with the extra liquid? Where does it go? It goes back in here. Why is that okay? because this has only ever been in here. This is clean relative to this because it's the only place it's been. So what you're going to do is you're going to hold this here. You're going to drip this down until it gets to 1 milliliter. Once it's at the 1 milliliter mark, you then release this. It sucks the 1 milliliter up into the bulb. You can take that wherever you need, and then you can dispense it where you need it, and then you just put this back and then put the lid back on. Does that make sense? So guys, that's the idea behind transferring. Read the steps and make sure these steps remind you of what you just saw. So use the pipette that's attached, squeeze the bulb, draw up the liquid, dispense the liquid back into the bottle until you get to the right amount, and then take that, put it where you need it, and then put the lid back on and put the pipette back. Good? You doing okay? And guys, again, I know that this isn't really like intriguing, thought-provoking material, but these are the things that you've got to be able to do in order to be ready for lab on Friday. We good there? Is that our last technique? What's our last one? Oh, dispensing and weighing solids. So guys, this is at the top of the next page, right? Okay, so guys, the last thing we need to do is talk about how to dispense and weigh solids. And again, the same thing is true. We're going to avoid contamination. And guys, again, never put chemicals on a balance. Always use a weighing boat. And then guys, we are going to use what is called the tap method to dispense solids. But never pour back into stock containers. Always use a spoon and dispose of your extras. So guys, it goes like this. Say that we're doing a lab and we want a gram of salt. So if we want a gram of salt, what are we going to do? Well, we're going to need some salt, and we're going to need a way to get the salt out of the thing. So here's what you do. So guys, again, we're never going to put chemicals on the balance. So what we do is we put the weighing boat on the balance, and then what do we do next? Put re-zero. So we're going to hit the re-zero button, and then we need a gram of salt. So here's what you do. You're going to take your spoon, and you're going to scoop up a bunch of salt. Then you're going to bring this over here, hold the spoon above the weighing boat, and start to tap on it. As you tap on it, you're going to see, obviously, the mass go up. And guys, you're going to sneak up on a gram. Now guys, the question is this. Once you get to a gram, what do you do with the extra salt? Back in here? No, because this is your spoon and you don't know that it's clean. So any extra chemical that you have either goes in the trash or it goes in a waste bucket. But guys, never put back into here, again, avoiding contamination. Now guys, what about this? What if you get a little bit too much? What do? Dump it out? What are you going to do if you get a little too much? Because all you got to do is scoop a little bit of it out. Now you're less than a gram. Then you can tap back up to the gram. Once you're exactly a gram, again, you just throw out the extras. Does that make sense? You okay? So guys, let me give you a second. Do you need to write notes to yourself about how any of this goes? That idea of taking out, putting back, never putting back in stock bottles? You guys all okay? Does that sit okay? Okay. So are we done then with techniques? So we got skills, we've got techniques. Guys, we've got one more thing to do, which are concepts and calculations. So let's take a look at this, and then you'll have the opportunity to work on some of your homework. So guys, you are now ready, or you've at least seen how to go into lab, how to use the lab equipment that you need to, and also how to dispense liquids, big and small amounts, and then also solids. So guys, what we need to do now is we need to talk specifically about the strategies that we're going to use to collect data. And guys, the conversation goes like this. When we find masses in this class, we are always going to use a process called mass by difference. Guys, please circle that in your notes where it says mass by difference. Guys, this is important. Some of you are going to feel like, hey, this is obvious, or I could have done that on my own, or there's another way that I want to do this. Guys, here's the deal. There is an accepted way in science to demonstrate these mass by difference processes. So guys, you might want to write a note to yourself now that you've circled this that says structure is important. Guys, it's important the way that you do this. This is not your opportunity to figure out what seems right to you. I'm going to teach you how to do this, and then I'm going to hold you accountable for how you do this. So guys, the trick is this. Anytime we weigh something in this class, we always want to know exactly what it weighs. Now guys, do you remember that question we had in homework a few days ago where we talked about weighing a beaker, then adding sugar, then weighing the beaker and the sugar, and if the balance is broken, we can still weigh the sugar because we're subtracting out the masses? That's what we're talking about here. So guys, when we find mass by difference, this is the idea. When we figured out how to use these balances, we learned that the masses may be incorrect due to errors in the balance. And so again, in order to overcome this, what we're going to do is weigh a container, add the stuff, and then weigh a container in the stuff, just like you saw in the homework assignment, question number 3 on the homework that we graded a couple days ago. So guys, here's what we're going to do. We're actually going to do this, and we are going to figure out the mass of some salt. Now guys, understand that this is also what you're going to be doing in lab in a couple days. And as a result, I want to show you how to do this well. So it goes like this. Guys, when you go into lab on Friday, you are going to be asked to weigh out about 1 gram of salt, but you need to know exactly how much the salt weighs. So guys, this is how this is going to go. Again, this is what you're going to be doing in lab on Friday. If you want to jot a note to yourself to remind you of this, over in that notes section next to this, you may want to write down, this is how to do it in lab, because this is what you're going to be doing. So guys, you need to go get 1 gram of salt in lab, and here's how you're going to do it. So guys, the first thing you're going to do is you are going to turn on the balance. Now that the balance is on and ready to go, it has to re-zero itself really quickly. Guys, the first thing you're going to do is you're going to put a weighing boat on the balance. What do you do next? Close to 1 gram of salt as we possibly can. So you're going to scoop this up and you're going to use the tap method. Closer, getting close. Oh, baby. That's pretty close. Okay, so guys, there we've got our gram of salt. But here's the trick. Do we know that that's actually 1 gram of salt? And the answer is we don't. That balance may not be accurate. And because that balance is inaccurate, we don't know for sure that that's actually 1 gram of salt. So how do we fix the problem? And guys, the answer is this. We know that this is about 1 gram of salt. We're going to move it off to the side. Then guys, what we're going to do is this. We're going to re-zero the balance and we're going to weigh a beaker. Write this down with me. The beaker weighs 30.52 grams, and you've got a place to write that in your notes. The beaker weighs 30.52 grams. Now guys, can you see what we're going to do next? Put the salt in the beaker. So we put the salt in the beaker. Remember, we can fold that over. And now guys, we record the mass again. And the mass of this is 31.51 grams. So now guys, the question is this. How do we find the mass of the salt? What do we do? Subtract. But guys, it matters how you do this. So guys, include this in your notes. Write this down with me. This is what this has got to look like. You've got space over in your note space to do this. Guys, write this down with me because this is what the calculation has got to look like. It goes like this. You are going to take the mass of the beaker and the salt. You are going to subtract from that the mass of the beaker, and that will result in the mass of the salt. This is how to structure this. It goes in columns. You write out exactly what you're subtracting. Mass of the beaker and the salt minus the mass of the beaker gives you the mass of the salt. And then you just plug in your numbers. 30.52 grams minus 31.51 grams. And then you bring that down. Notice, guys, we lined up our decimal places. We're structuring this well. And guys, when we do that subtraction, that's 0.99 grams, right? No. Yes? No. Oh, I did it. Oh, gosh, guys, I'm sorry. I told you my head is fuzzy. Sorry, guys, this is upside down. My bad. Thank you. So, guys, the mass of the beaker and the salt is 31.51 grams. The mass of the beaker is 30.5. There we go. And this then is 0.99 grams. So that then, guys, is the way that we represent this calculation. Now, guys, again, understand, I know most of you could have done this in your head. I know that there's other ways to represent this subtraction, but guys, this is what this has got to look like. This is the way to handle this calculation. So you guys good there? And you're going to be doing that in your labs on Friday as well. We good? Okay, guys, we got one more thing to talk about, and we're going to wrap it up for today. So, guys, the last thing that we need to talk about today is significant digits and representing error. So, guys, this is the deal, and I know you have this in your notes, but we are now ready to take this idea of significant digits and apply it to the data that we're collecting in lab. And, guys, these are the rules. When you are multiplying and dividing in this class, and guys, we'll show you some examples. When we're multiplying and dividing in this class, we will always limit the number of significant digits in our answer to the least accurate number in the calculation. When we're adding and subtracting, we don't care about significant digits. We care about decimal places. So guys, let me show you what this means. You've got these down here at the bottom of your page. Grab a calculator if you need. And guys, run those numbers. Do that math. Do it with me. Grab a calculator, do the math. You can grab your phones if you need. This is pretty straightforward. But guys, do the math with me. 125.50 times 2.3. 288.65. Okay. Now, guys, understand that is the mathematical result, but that's not the answer. You may want to draw this arrow just so that you understand what the rule is. Guys, we've got to apply this rule. When we do multiplication or division, guys, we have to round our answers given significant digits. So guys, do this with me. How many significant digits are in 125.50? Is it 4 or is it 5? Remember significant digits? Guys, is that 0 significant? It's a final 0 after the decimal, so you may want to write this down with me. There are 5 significant digits in that top number. Now, guys, the bottom number, 2.3, how many significant digits? That one's only 2. So, guys, what that means is we've got to round our answer to 2 significant digits. So, guys, what's 288.65 to 2 significant digits? Well, here's 1 significant digit. There's 2 significant digits. What does the second 8 tell us to do? Round up. So this would be 290. So guys, when you're multiplying and dividing, we will always round to the fewest. So guys, try this one. When we add and subtract, the numbers work out differently. Do this math. You can do it on paper. So here, when we do the subtraction, we have 123.42. 0.20. Did I do that right? My brain, it's right? Okay. So guys, here's the question then. What do we write down here? Well, on this one, this is the rule that we're looking at. We don't care about significant digits. When we're adding and subtracting, we care about decimal places. So guys, there are 2 decimal places in the top number, 0.50. There's 1 decimal place in the bottom number, 0.3. So we get the fewest decimal places. So that means we only get 1 decimal place. So this would be 123.2. Guys, do you feel like you're drinking from a fire hose? That this is just like a ton of information? Again, it's the skills and things you need to be able to do to be successful in lab. Does that sit okay? 1 more thing to do, 3 more minutes, done for the day. You guys good? Okay. So guys, the last thing that we need to talk about is this. This would be another thing that you want to circle because it's a big idea. Guys, the last thing that we need to talk about is what is called representing error. Guys, when you go into lab, you are going to be collecting data and doing calculations. And at the end of those calculations, the last thing that you're going to do is you are going to answer the question, how did I do? Did I do well in this lab, or did I make so many mistakes that the lab didn't turn out well? And guys, sometimes you'll answer that question qualitatively and you'll talk about, no, the lab went okay or whatever. But guys, many times we'll do this mathematically. And we do this through what is called the percent error equation. This equation allows you to calculate how well you did in lab. And guys, this is the equation. You don't need to write it down because you have it in front of you. But guys, let me tell you right now, you will never memorize equations in this class. Did you catch that? You will never memorize equations in this class. This will be given to you on the test, and it will be available to you in your notes when you're writing up your labs. So you don't have to memorize this, but you do need to understand it. So here's what this means. The measured value is the value that you measured or calculated. The accepted value is the correct value. So basically what you're doing is this. What you got minus what you should have got divided by what you should have got times 100. And that will give you the percent that you got wrong. Now guys, one question. Do you know what those vertical lines mean? Good for you, Spencer. Absolute value. And do you know what that means? Yeah. Yep. So let me ask you a different question. What can that number then never be? Negative. Good. Did you guys know that? Okay. So this then is how this goes, guys. Do this with me in your notes. So it says this. The next time in lab, you collect 1.03 grams of salt. And then at the end of the lab, you only collect 0.78 grams of salt. What is your percent error? And guys, you'll notice in your notes, I didn't give you the solution, but you've got a lot of space down here at the bottom. Guys, write this down with me. I'm going to show you how to solve this. Write this down. This is maybe a little trickier than you know. Write this down. Don't phase out yet. We're almost done, but get this down. So guys, the first thing you need to do is write down your equation. Do it with me. First thing you need is the equation. Oh, excuse me. So percent error is measured minus accepted divided by accepted times 100. Have you guys seen this? Did you guys do this in physics? Some of you have done physics, right? Did you do percent error in physics? No? Okay. Okay, so then guys, what we've got to figure out is this. Which number is which? So here's the idea. Reading the question again, it says you go into lab and you expected to end up with 1.03 grams of salt. When you were done with the lab, you thought you were going to get 1.03 grams of salt. You only got 0.78. How did you do? So guys, the first thing you've got to do is figure out which number is which. So guys, the 1.03 grams of salt, is that the amount you did get or the amount you should have got? Should have got. That makes it your accepted value. That's your goal. But then guys, the trick is that's not how much you, but you only measured 0.78 grams. So now we've got our numbers. So guys, let's plug in our numbers. So percent error is equal to our measured value, which is 0.78 grams, minus our accepted value, which is 1.03 grams, divided by the 1.03 grams. Now guys, let me encourage you to do something. Put a star next to this step. This is where this is going to mess you up. Guys, here's why. When we solve this, we do the subtraction first. So we've got 0.78 minus 1.03. If you need your calculators, 3. When we do the math, I know you can come up with the answer, but here's the question. What are we going to write down? And the answer is this. It depends on the number of decimal places. Remember what you learned. We're subtracting. So guys, how many decimal places in 0.78? 2. How many decimal places in 1.03? 2. So guys, when you do the subtraction, you need 2 decimal places in your answer. So the answer is going to be negative 0.25. Watch out for decimal places when you do the subtraction. Then guys, we're still going to divide that by 1.03. And then again, the absolute value means it'll be positive. So now we need the answer. And guys, when we do the math, we have 0.25 divided by 1.03, and we're going to multiply that by 100. And guys, I get 24.27184 and so on. But guys, that's not the answer. Because now we're dividing, and when we divide, we round to significant digits. So guys, how many significant digits are in 0.25? 2. How many significant digits are in 1.03? Actually 3, the zero's trapped. So this would be 3. And so guys, when we do that division, we're limited to the smallest number. That's 2 significant digits. So this would be 1, this would be 2, and that would be 24 then percent. Okay, so guys, here's the trick. That was a ton of information. It was skills, it was techniques, it was concepts, it was math. That was a ton of information. So guys, some of you are right now sitting there going, oh my gosh, I know that I need to know all of this stuff. I'm going to go into lab and this is going to be a train wreck. Guys, let me put your concerns to rest. Here's what we're going to do. Guys, 2 things. The first thing that you need right now is you need the opportunity to process all the information that we just went over. Guys, this is your homework assignment. We're going to grade this on Friday. Let me get it in your hands and then we'll talk. So guys, let's talk about this first, and then we'll talk about the lab on Friday, and then you'll probably get your homework done today still. Okay. So guys, on the front of this page, there are 7 problems where you are doing the calculation that is up on the board, calculating percent. I would propose to you that if you can do a couple of these, you can probably do all of them. When Miss Call and I wrote this assignment, we got a little carried away. So what I'm going to suggest is this. Let's do number 1, and let's do number 7. Those two we are going to be held accountable for on Friday. Guys, if you want to do the rest of them for practice, that's fine. If you don't agree with me that 2 is enough, feel free to do more. But guys, please do number 1. Please do number 7. And then if you want to practice on more of them, all the answers are posted on our website. But let's do 1 and 7. Okay? Then guys, on the back. These are the things that are going to help you get a sense of whether or not you understand everything that we covered today. Guys, answer these questions, making sure that you have a handle on the concepts that we covered today. So guys, homework is due on Friday. We're going to spend the remainder of today working on it. And again, guys, when you go into lab, all sorts of new experiences that you're going to have in lab. Because I don't expect you to be perfect. I just expect you to try. And we're going to get in there and we're going to work through this stuff together. You're going to find it's a great experience. Don't be overwhelmed. But guys, we're going to go and we're going to get started in lab on Friday. So guys, the remainder of the time is yours. Let's get this homework done. And then guys, we'll get together on Friday. We'll grade the homework and then we'll get you right over into lab. You guys okay? Remember, the answers are posted on our website if you'd like to check as you go. So guys, let's get this homework finished up. Go get them. That went a lot better than I thought it would. Did we do okay? Oh, good.